Okay, in this video, we're going to look at a former AP multiple choice question as well as a derivative with polar. So we've got an area question here. It says the area of the region inside the polar curve and outside the polar curve is given by. Now, normally I would like to show you a graph of this, and that's certainly if you had the ability, that's how I would do it. But this was a no calculator question. So here's what we need to think about. Area is 1/2 the integral of r squared d theta. Now, if there was if we're doing a curve and another curve, then how we usually do it is subtract out the other curve. Now, because there's the, I guess, likelihood that the bounds are the same, we can put these integrals together. We can factor a 1/2 out and have r squared minus, r1 squared minus r2 squared. I guess I should, maybe designate that they're different equations. D theta. Assuming the bounds are the same. If the bounds aren't the same, of course, you can't put these integrals together. But I point that out because you'll see that some of these have r minus r squared. That is not what's happening. We square the functions individually. So I'm going to right away cross out any of them that have the squared around the function's difference. That's not what we want. We want the difference of the squares, not the square of the differences, okay? And that's a subtle difference, but it's important. So now we're down to just needing to know what the bounds are. So the easiest way to find the bounds without a calculator is to simply set the two equations equal to each other and see where they intersect. Well, if I'm looking for where sine is 1/2, that's at pi over 6 and 5 pi over 6. And even if you didn't quite know that, I think you could definitely rule out that it's 0 and pi. So this one is out. So the answer is D. Again, this is being a no calculator question. That's difficult to sometimes do, but we had the ability to reason our way through it, knowing that we had to square the functions individually and then finding the bounds by just setting the two equal to each other. You could graph that and verify that, in fact, it is correct, but don't be thrown if it's a no calculator. We still have ways to figure out which integral would do the job. Okay, in this, we're going to find the slope. So let's remember derivatives in polar are dy d theta divided by dx d theta. So what we need to start by doing is reminding ourselves that y is r sine theta. So r multiplied by sine theta. And x is r cosine theta, which for us is r cosine theta. Okay, so to do the derivative, we would do the derivative of y. So first, times derivative of the second, plus second, times derivative of the first. The x, first, times derivative of the second, plus second, times derivative of the first. And we've been asked to find it at the point 2 pi. Of course, the 2 is r. These coordinates are presented as r and theta. Well, we don't have any r's in our derivative, so we're just going to plug in pi for theta. Now, the sine of pi is 0. So let me kind of go through this. So we're going to have 2 minus 3 times 0 times the cosine of pi, which is -1, plus 0 times -3 times -1. So the top, we're going to have, well, let me do the bottom as well. So we're going to have 2 minus 3 times 0 times 0 plus negative 1 multiplied by negative 3 times negative 1. Okay, so the top, we're going to have 2 minus 0 times negative 1, so negative 2 plus 0. So the top is just negative 2. The bottom, we're going to have 2 minus 0 times 0, so this is 0, and then negative 1 multiplied by positive 3, which is negative 3. So the final slope is just 2/3.